All right. So let's take a look at the sheet that I just gave you. We've got this beautiful colored paper. It's such a nice color. Like a blue purple or something. All right, everybody. So sets of numbers today. All of the numbers that we are going to talk about, guys, are you with me? All of the numbers that we are going to talk about are real numbers. Yes, that is literally their name. So there are numbers that are not real numbers, and they're called imaginary, which is crazy. You won't deal with those until you hit algebra 2. But in the real number system, which is all of the numbers we are going to be talking about this entire year, they all fit into somewhere in this box. Okay, so real numbers are made up of two different types, the rationals and the irrationals. So you can see that there are no overlap between rational, this box, and the irrationals over here. They are completely separate, but together they make up the real numbers. Okay, so I'm going to give some definitions just down here at the bottom. So if you'd rather do this in a notebook, that's fine. So real numbers, let's see if this comes out legible.
I feel like I still have these notes from last year.
You probably do. I would just take that. I'm not writing much because most of it is already on the paper for you. Okay, the real numbers, these are just made up of the rational and irrational. Try this black pen. So that's the real numbers. They are literally just made of the rationals and irrationals together. So if you take those two groups of numbers, put them together, you have all of the real numbers. What in the world are the rational and irrational numbers? Well, that's a great question. Does anybody know? You can look at this is called a Venn diagram, by the way. Look at the diagram and see if you can figure out what's the difference. What makes a number irrational and what makes a number rational? Why are some over there and some over there? What's the difference? Go super fast, please. Anybody have a thought? What makes a number rational? What makes a number irrational? I'll tell you. I'm going to start with the irrationals. These are all going to be decimals that never end and never repeat. That's what makes a number irrational. So if you call a person irrational, I want you to think like you're calling them like, hey, you're being irrational. You're not making any sense. It's a little chaotic here. That's the same thing as an irrational number. They're chaotic. They just keep going forever and there's no pattern. They just go. Now, if you look in the diagram, we have a bunch of numbers in there that don't look like what I just said. They don't look like they're decimals that never end or never repeat, but they are. So here's one. You know pi, right? You're familiar with pi as a number? What is it? What does it equal? What is the number for pi? Anybody know?
I don't know.
Maddie? Yes. So it's approximately 3.14159, and then I'm going to put dots after it because it just keeps going. If you look at it on a calculator, so let me push the most scientific and graphing calculators have an actual button for pi. Look at what shows up on my calculator screen. You get all of these digits, and they really do keep going, but a calculator can only show you so many digits. So that's what you get so far. But if you put it on a computer, you'll get more digits. It just keeps going. And it's random numbers. So the same thing happens if you look at the square root of 2. I know it looks like a nice number, but if you turn it into a decimal, look what the square root of 2 is. Oh, what did I do? Oh, I put it the wrong way. There we go. Square root of 2. Look at that number. You just get this random crazy decimal that just continues on and on and on and on, and it never repeats. And it's just a kind of a mess. It's chaotic. It's irrational. Okay, so that's our favorite examples of irrational numbers. People always say pi. And then it's also all the, now don't get confused though, because it's not every single square root that exists, right? If I ask you what the square root of 9 is, that's just 3. That's not an irrational number. It's all the weird square roots. I already have addressed that. Oops, I spelled weird wrong. You can also make up an irrational number, right? So if you are asked to just state an irrational number, you can literally just make one up. You can do like 2.13790 ... If you put the ... after it, that indicates, hey, this number is just going to keep going forever. You also see that it's not a repeating decimal. So one of the decimals that we can rewrite with the bar notation, those do not count here because those do repeat. These are only ones that never and never repeat. They're completely chaotic. Okay, so those are the irrationals. If it's not irrational, then it's a rational number. Okay, because we're not even going to talk about the imaginary numbers until algebra 2. So every other number that you're going to come into contact with, if it's not irrational, it's going to be rational. There's no overlap between the two. A number can't be both. It's one or the other. So let's talk about those irrational ones now. Rationals. These are the ones that you can write as a fraction. Where numerator and denominator are integers. You might not remember what an integer is, but I will tell you in just a moment. So this is basically everything else. So these decimals can repeat. they can end. So you could have 1/3, you could have 0.75, you could have even regular numbers like, I don't know, 6, that counts, right? Because I could write that as a fraction if I wanted. You can have negative numbers, so -2/3, let's say. You could have something written in bar notation, so like 0.45 repeating, something like that. Should be as integers, not are integers. Okay, then what are the integers? Easy. You're gonna hear this word all the time, and a lot of kids don't know what it is. Do any of you know? Does anybody tell me right now before I tell you? Okay. That's exactly it. Positive and negative whole numbers. That's all it is. I don't have any decimals or fractions. I just have whole numbers and their negatives. No decimals, no fractions here. So we're looking at -5, 3, 2, -7, 15. 0 counts because 0 is a type of whole number. So any of these, notice no decimals, no fractions. Don't get confused though. I could try and trick you by doing something like 30/10. Isn't that really just the number 3? So even though you're looking at it, you're like, oh, that's a fraction. If you simplify it, it's really just a whole number, just 3. Okay, so be careful. And then we're almost done. We just got to talk about whole numbers and natural, and there's only one teeny tiny difference between those two. Whole numbers. Whole numbers. These are your counting numbers and 0. So whatever you count with, we start counting at 1, 1, 2, 3, 4, 5, and so on forever. But we also include a 0 in our whole numbers. And the only difference between the whole numbers and the natural numbers is that the natural numbers just don't include 0. These are just the counting numbers. So 1, 2, 3, 4, so on forever. So I guess wholes would be 0, 1, 2, 3. That's it. So that's what they all are. I know you have seen this before, but I can't tell you how many times kids think they know these and they have no idea. So we're going to find out. Do you actually know what these are? I don't know. Hopefully now. So how about this? I'm going to state a number. You tell me which of these sets of numbers best describes that number. Okay, so it's most specific grouping. We'll start off easy. How about 10? What is the best descriptor for the number 10? It fits into multiple of these groups, but what's the first group that it fits into? Sophie? You can go even smaller than that. Yeah, natural numbers, because it's a counting number, right? You learned to count to 10 when you were a kid. Counting numbers. So 10 would be a natural number. All right, give me the best one for 2/7. The fraction 2/7. So what you can do is you can start, if you're using the Venn diagram, let me just show you how to best use this. You could start on the inside and work your way out. So I always start with the inside bubble, natural numbers. 2/7, does it fit in there? No. So then I go to whole numbers. Does it fit in there? No. Integers, does it fit there? No. Rational, does it fit there? Yes. So there's our best descriptor for 2/7. What about the number 0.5? Just 0.5. Oh, it's already on this list. I'm going to change it. Let's change it to 0.5 repeating. If I had the bar over it. If I asked you to put 0.5 repeating somewhere on this, that would be irrational. Oh, wait, no, it wouldn't. What'd you say? Did you say rational or irrational?
Rational.
You are right. Rational. It would be a rational number. Anything that repeats is rational. So if it has the bar, it automatically goes under rational. What about the number -9? Woo! Yes, you're right. Are you super good at these?
What?
Are you super good at these?
It's showing it right here.
Well, not everybody knows. But you're right. -9 would be an integer. All right, flip your papers over. If you look at the back, try and fill this out without flipping it over back to the other side. So if you look closely, you've got some, see there's places for you to enter in the names. So I want you to start with that. Enter in the names. Here they are. You've got, I list them for you in alphabetical order: integer, irrational, natural, rational, and whole. So put those, what is that, 5? Put those 5 words where you think they belong. Start with that. Don't put any numbers down yet. Don't flip your paper over. Do it as best you can. Think about what these things mean. Think about where they go. So take those 5 words: integer, irrational, natural, rational, whole. Put them where they belong.
Oh, you got it.
Don't do the numbers yet. Just put the words.
Oh, okay.
Does everybody have the words where they go?
Not yet.
All right, let's try the words together. Let's start with the easy one.
Hold on.
I'll give you like 10 seconds.
Yeah.
You got them?
Yeah.
All right. So let's start with the easy one. What one has to go over here? Which is the one that's kind of separate?
That's irrational.
That's the irrational. So double check that you have irrational there. Okay, that one's done. Now on the other side, what's this top one? That's where the rational goes. So remember, the real numbers are just made up of these two put together. Okay, there's nothing that's a real number that doesn't fit into one of these two. It's just these two put together. It's like, trying to think of something that's, I don't know. I don't have a good example. I don't know. Anyway, all right, rationals. What's the first bubble under the rationals? Yes, integers. Then whole, you say, I agree. And then the last one is natural. So if you take a look at the Venn diagram, where the bubbles are matters. All of the natural numbers are contained within the whole numbers. That means if a number is a natural number, it's automatically a whole number. All the whole numbers are contained in the integers because every whole number is an integer. But there are some numbers that are integers that are not whole numbers, right? And all of these numbers would all be contained in the rational. There is no overlap between rational and irrational numbers. Okay, let's try and put some of the numbers down. Have you done that yet?
Yep.
Did everybody put their numbers down? I didn't tell you to, so if you did, that's okay. You can tell me one of them.
Rational is the beast.
Oh, the square root of 7. And where did you put it? Irrational? Yes, I agree. So square root of 7 is going to belong on our irrational side. If you don't know what the square root of the number is, it's probably irrational. So I have no idea what the square root of 7 is, but I do know what the square root of 9 is, right? Because it's just 3. So be careful. Not all square roots are irrational because you got to stop and think. Do I know the square root of 16? Oh yeah, it's just 4. So then it would be a natural number. Be careful. All right, that one's done. Where would I put 1/2? Rational, yes. Fractions have to go in the irrational section. 0. Natalie.
Whole numbers?
Yes. Remember, that's the only difference between natural and wholes, is that the whole number includes 0 and the natural numbers don't. We already did square root of 7. Where do I put -4? Sophie? Yes, integer. That's the first time that I have negative numbers. So integers are the positive and negative whole numbers. Where would I put just the number 9? Natural, thank you. Because that's just a counting number. 2.3 repeating with that bar over it.
That'd be irrational.
Did you say rational or irrational?
Rational.
Yes, sorry, it's a little hard to tell the difference between the two. 2.3 repeating is absolutely rational. Anything with a bar over it is automatically rational. And then the next number is pi, which, may I remind you, Pi Day is around the corner. March 14th.
It's today's Valentine's Day.
We have a month until Pi Day.
Oh, they give out pies here.
We have in the past, so fingers crossed.
Watch them.
Were you not here last year for it?
I'm from Western.
Oh, well, welcome to Fantastic. This is your first year here? Oh, I didn't know that. All right, pi, where does it go? Natalie?
Irrational.
That's an irrational number. That's probably our favorite irrational number. Never ends, never repeats. It's a wild number. And last one, the number 16? Natural. Okay, we will pause there for lunch.
Lunch or is this through the cafeteria and auditorium?
All right, see you afterwards.
Excellent.